Salut, numele meu este Tibi. Dacă îmi permiți, eu o să încerc să cresc numărul de cuvinte în engleză din prezentare de la 10% la 100%, așa că bear with me from now on. Right, so we heard about NoSQL, big data, and I thought this presentation should really be about Kafka, the author, but I don't think you're here for that, are you? So back to Apache Kafka, which is a high throughput distributed messaging system. It's also what I would call a Node.js solution. If you're familiar with JMS, the Java messaging API, this is not really a JMS solution. Like any solution whose name starts with a node, it's scalable and resilient. It has different messaging pattern as opposed to JMS. Also, the consumption tracking model is a bit different from JMS. And obviously, it wouldn't be no JMS if it had a JMS API. So I said in the beginning that it's a high-performance system. So really, how fast is it? Am I talking hundreds of messages per second, maybe thousands of messages per second? Actually, I'm talking more about 2 million messages per second on a 3-node cluster of cheap machines. Now, some people would call a machine with 6 cores, 32 gigs of RAM cheap. Maybe that is, maybe it's not, I don't know. Anyway, that's something that was measured at LinkedIn. They did the benchmarking. This is the numbers they plot. Obviously, if you try it on your own, you're probably going to get more or less. So it's just a reference. Why is it so fast? How come it's so fast as opposed to the other traditional messages, which only handle like thousands of messages, tens of thousands per second? It's because it's built on 2 observations done in the 60s, so it's not a new technology. One of them is that sequential disk I/O is fast. That is, if you write to disk sequential, it's going to be fast. No matter what the SSD manufacturers tell you, disk is still fast if you write sequentially to it. Also, message publishing is sequential. So if you publish messages that's inherently sequential, you have one message after the other after the other. So if you combine the two, obviously sequential message publishing to the disk is fast. Right. So how will that make my system faster? So 2 rules. If you get a message, write it to the disk sequentially. If you get another message, write it again to the disk. This is going to be fast from the first discovery. Second rule, if you need to serve messages to your consumers, read them off the disk and send them sequentially. Obviously, this is going to be fast because of the previous observations. And most importantly, don't care. Don't bother taking care of who consumed what, right? It's the consumer's problem, not yours as a message broker. Don't bother. So, but then what you do with the messages that have been already consumed, right? You don't need those anymore. Well, just keep them there. Don't bother. Keep them for 4 hours, keep them for 10 hours, doesn't matter, keep them there. But that's just weird. I mean, we don't need those messages there, why would we want to keep them, right? Make no sense. That's just stupid. It's supposed to say stupid over there. Did that. But it's also very simple. It's simple because you don't need to do any kind of housekeeping, right? You just write the messages. Once those are old enough, you just wipe them off the disk. Write them to different files. When they're old enough, delete those files. Nothing to do here. This is also good because you don't need to seek anywhere on the disk. Right? You don't need to do any kind of compaction, any kind of marking, anything that touches the disk besides writing new messages and sending them off the disk. So then how do you track progress? How do you know what message to send to your consumers? They need to get every message. And the trick here is this. You have an offset for each consumer. You know which message was last sent. The next message to send is the one with the next offset. It's really that simple. You have a list of messages, you send them one after the other. That's it. No fancy tracking of this has been consumed, but the previous one wasn't, and the two before weren't, and then send those two, but not this one. Just send them all sequentially. Okay, well, right. But I still need my JMS. I'm still in a Java corporate environment, JMS rules, I still need that. Why aren't you providing JMS API? This is because of a paradigm mismatch. Traditional messaging systems had two ways to consume messages. One of them was the queue. Right? You put messages in there and then you spread them, and one consumer gets a message, nobody else. The other is the typical publish-subscribe model, in which everybody gets everything. This is the traditional broadcast. You just push everything up there. So what Kafka does is basically it combines these two. So it offers kind of a publish-subscribe model, but it has a twist, right? Instead of having each individual consumer subscribe to a topic on which you publish messages, you basically have groups subscribing. Now, within a group, what happens is the group works like a queue. You basically have only one consumer within the group getting a message. So there is a fancy diagram. What happens here is that, for instance, message 1 is published to the broker. Message 1 got to the first consumer from the first group and to the fourth consumer from the second group. Right? The same with message 3 got to the second one and then the fifth one, which is in the second group. So basically, if you count the messages, you will see that every message hits every group, but within the group only one consumer. So why is this good? It's good because it offers load balancing. You can dynamically add and remove consumers from the group, depending on your load. If you have more messages, add more. If you don't need them, just remove them. It will rebalance itself. But if you really want your old school queue and publish-subscribe semantics, you can still do that, right? What you will do is, if you need a queue, you just have every consumer in the same group, right? And then it will basically spread out the messages among them. If you, on the other hand, want a topic, then have a separate group for each consumers, because the consumer is, there's only one consumer within a group. It's going to act as a traditional pub/sub mechanism. Everybody will get it. So internal stuff, like hardcore, gory implementation details are really in the article. So I invite you to read the fine article. If you've heard any other acronym or any other explanation for this acronym, the F stands for fine and not fine. Final conclusions. So, as you've seen in Kafka, is fast. It's fast because it's simple. It eliminates a lot of the boilerplate that other systems do. It's JMS free, which might or might not be what you want, or might not be in your advantage. And the final slide with the questions. And this is very common. Yeah.
Did you try to use it in 2 different data centers?
Currently, no. There are deployments that do that. They basically have a different agent that consumes from one data center and pushes messages to the other data center.
And why I'm asking that, we tried to evaluate this last year, and the version was 0.7, I believe. And the issue that we had, the zookeeper took it somehow crazy,
yeah.
And
we had the same problem.
Was a mess.
Yeah.
So single cluster, it's fine, but 2 different data centers and keep them on the same was a mess.
Zookeeper is in general a mess because it's really latency sensitive. So
yeah.
You have to run it on physical hardware, guarantee I/O paths. It's a bit messy. We've also had problems with the latency.
Okay. So you use it only internally in one data center for tracking something?
Regarding benchmarks, we did an internal benchmark on basically lot less powerful cluster. We got to, I think, 800,000 messages per second. Not as fast as what the LinkedIn guys did, but we were
on the payload.
yeah, we were running VMs, not physical machines. Yeah.
Do you know which are the key differences between Apache Kafka and Apache Flume?
I'm not really familiar with Flume, so I think it's a distributed log.
I think they solve the same problem.
Yeah, I'm not familiar with Flume, so I can't really say.
Based on streams in general.
I think they might have used. I mean, they might be used for the same purposes like log shipping. So typical use case for Kafka or event sourcing.
What happens if one of your servers is crashing? How is the high availability is resolved?
Good question. So basically what happens is that each topic is divided into partitions. Every partition is replicated on another node. So basically if one node goes down, then you have its replica still there. And then what happens is that you start consuming and producing to the replica. Once the node comes back, you then basically syncs everything back. And this is handled through keeping sessions in Zookeeper. So, and then you control the replication factor, so you can have like 4 different replicas as much as you want. Obviously, each replica will add to your publication time because it needs to sync everything, publish to multiple places. So then there is a price to pay for resilience.
Doesn't use memory at all, only disk?
So it uses basically a really interesting twist. It doesn't use memory, but it uses memory. So what it does is basically it writes to the file system. Now every write is cached by the operating system, and every read, then if it's in the page cache, then it will be served from the page cache. So basically, if you have consumers and producers running at the same time, everything's going to come out of memory. What you use disk for is resilience.
Or on the same machine.
Yeah. But what happens is that each consumer will own a partition and will fetch messages from that partition.
And when a node goes down, the replication factor starts at that point?
I think the replication factor is the total number of replicas you have. So replication factor means a single replica. If that goes away, it's boom. Replication factor 2 means one master and another copy, backup
Yes,
copy.
but I mean,
Last question.
The main partition is down.
Well, if the main partition is down, then your replica will gonna be promoted to a main.
It's only one?
Only one. It's always one master and several copies all the time.
Okay, thank you.